Effect of supplemental yeast culture and dietary starch content on rumen fermentation and digestion in dairy cows. The objectives of this experiment were to evaluate the effect of feeding a culture, Saccharomyces cerevisiae, on rumen metabolism and digestibility when cows are fed diets varying in starch content. 4 lactating Holstein cows were assigned to a 4x4 Latin scale design with a 2x2 factorial arrangement of treatments. Treatments were low starch, 23% of diet dry matter, and low yeast culture, and LS and 15 grams of yeast culture per day. High starch, 29% of diet dry matter, and no yeast culture. And high starch and 15 grams of yeast culture per day. Periods lasted 28 days, with the last 9 days for data collection. Days 20 to 24 were used to determine production, nutrient flow, the digestibility. On day 25, 3 kilograms of corn grain dry matter was placed in the rumen. 1 hour before the morning feeding. 1 hour before the morning feeding, the yield of milk and milk components were measured after the challenge. Blood was sampled -1, 3, 7, and 11 hours relative to the morning feeding on day 24 and 25. Rumen pH was measured continuously on day 24 and 25. Rumen pillape were collected on day 24 and 28 to quantify. Rumen pillape were collected on day 24 and 28 to quantify mRNA expression of select genes. Supplementing yeast culture increased the yield of milk, 26.3 versus 29.6 kilograms per day. Energy corrected milk, 26.5 versus 30.3 kilograms. Fat, 0.94 versus 1.08 kilograms. True protein, 0.48 versus 0.96 kilograms per day. And ECM dry matter intake, 1.15 versus 1.30. Compared with the control, but did not affect dry matter intake, 22.6 versus 22.9. Cows fed high starch had increased milk true protein percentage, 3.18 versus 3.31%, and yield 0.87 versus 0.94 compared with cows fed low starch. Feeding high starch yeast culture increased the portion of dietary and incorporated into milk true protein from 24.9% in the other three treatments to 29.6% portion of dietary and incorporated. Feeding high starch increased the concentration of propionate 21.7 versus 32.3 millimole and reduced the NH3-N 8.3 versus 6.7 milligram per dl in rumen fluid compared with the control. And the combining high starch with yeast culture in high starch yeast culture tended to increase microbial N synthesis compared with low starch yeast culture. 275 versus 322 gram per day. Supplementing yeast culture to cows fed high starch reduced plasma hemoglobin. Supplementing yeast culture to cow fed with high starch reduced plasma hemoglobin and rumen lactate concentrations, increased the mean rumen pH, reduced the time with pH below 6.0, and prevented the decrease in rumen neutral detergent fiber digestion caused by high starch. Prevented the decrease in rumen neutral detergent. Increased the mean rumen pH. Reduce the time with pH below 6.0 and prevented the decrease in the neutral detergent fiber digestion caused by high starch. Cows fed high starch had less total tract digestion of organic matter. Cows fed high starch had less total tract digestion of organic matter. 73.9 versus 72.4%. Cows fed high starch had less total tract digestion. Organic matter. (73.9) versus 72.4% because of reduced exceed detergent fiber. 57.6 versus 51.7%, and neutral detergent fiber 60.9 versus 56.7% digestibility. Production performance after the challenge was similar to that before the challenge. The yeast culture improved yield of ECM. After the challenge, supplementing yeast culture tended to reduce rumen lactate concentration compared with the control and reduce the heptoglobin in cows fed high starch. Feeding high starch but not yeast culture increased the expression in rumen pilape of genes for receptor, but not yeast culture increased the expression in rumen pilape of gene for receptors and transporter of short-chain fatty acids, but did not affect gene involved in transport of natrium plus, hydrogen plus, or water, or in inflammatory response. Supplementing yeast culture to dairy cows improved lactation performance in diets containing low and high starch. Supplementing in yeast culture to dairy cows improve the lactation performance in diets containing low and high starch, and mechanisms might be partially attributed to improvements in rumen pH. Digestion of fiber, microbial enzyme synthesis, and reduction in acute pace response. Digestion, rumen fermentation, starch, yeast culture. Introduction. Supplementing yeast culture to dairy cattle diets is a common practice because of the potential beneficial effect on yields of milk and milk components. Nevertheless, the effects of yeast culture are heterogeneous and dependent, among other factors, on the stage of lactation when supplementation starts. One of the reported benefits of yeast culture is the improvement in efficiency of feed utilization, presumably because supplementing diets with Saccharomyces cerevisiae improves OM digestion, results in a more stable rumen pH, and might increase microbial N yield. One of the potential sources of heterogeneity in response to yeast culture is component of diet. One of the potential sources of heterogeneity in response to yeast culture is the composition of the diet. The authors observed an interaction between diet composition and supplementation. One of the potential sources of heterogeneity in response to yeast culture is the composition of the diet. The authors observed an interaction between diet composition and supplementation with yeast culture because the benefit in FCM yield was greatest when cows were fed a diet with 60% compared with 50% concentrate contents. Diets with increased concentrate content are more prone to negatively influence rumen function because of the depression in rumination and salivation and the increase in exit load, which can depress pH. Diets with increased concentrate content increased concentrate content are more prone to negatively influence rumen function because of the depressions in rumination and salivation and the increase in exit load, which can depress pH. It is known that YC and live yeast products attenuate challenges in rumen pH, in part by reducing lactate accumulation in the rumen fluid because of stimulation of microorganisms that metabolize lactate into short-chain fatty acids.